Hello everyone. Welcome to this session on understanding how we ensure the quality and safety of the materials and components. I am Muthulakshmi Kanagaraj, a quality expert with ASNT Level 3 certification in 10 methods along with the API, PMP and Frosio Level 3 certifications. Now we are going to discuss about two fundamental approaches in material evaluation and quality control. What are the two types that are destructive testing and non-destructive testing? Let's start the destructive testing. So destructive testing is one of the method that where the material is tested to the point of damage or failure. So destructive testing involves damaging or destroying a material or component. This helps us to understand materials mechanical properties like tensile strength, yield strength, toughness, ductility. So these mechanical properties are determined by this testing. So we need to find out how strong is the material. You push it until it breaks. Because the material is destroyed, the test specimens are usually scrapped after testing. So the primary purpose of destructive testing is determine the mechanical properties like strength, ductility and how much force we can withstand before it fails. Example, imagine you buy a new type of safety rope and you want to know its exact breaking point. You would set up a machine like this is upper clamp, this is lower clamp. You set a rope in between of these clamps, set up a machine to pull the rope tighter and tighter until it breaks. The rope is destroyed. But now you have a precise number for its ultimate strength. That's destructive testing. Here I mentioned some methods in destructive testing, that is tensile testing, impact testing, bend testing and fracture toughness testing and hardness testing. These are some methods in the destructive testings. What is tensile testing? Exactly like a rope example. We literally pull a sample until it breaks to measure its ultimate tensile strength. That is the maximum stress it can withstand before fracturing. Impact test means where we measure how much energy a material can absorb before it fractures. These tests push the material to its absolute limits. Imagine hitting a piece of metal with a special hammer to see if it shatters or deforms. This is impact testing. Other common methods include bend testing and hardness testing, fracture toughness testing. These are other common methods. Each method has specific insights into a material's behavior. So next we discuss about advantages and disadvantages of destructive testing. First, advantages. It provides the actual performance limits. Destructive testing has providing a real and accurate material performance data. So it provides accurate measurement of tensile strength and the impact testing absolute limit, how much energy it absorbs. So accurate performance data it will provide. Then reveals detailed mechanical property. It includes how the material behaves under stress. So these are the advantages. And what are the disadvantages? The sample is destroyed. This is the biggest drawback of this method. You can't use the tested part again. So it is not suitable for testing in service components. It is not suitable like pipelines or aircraft often more costly and time consuming due to specimen loss. You have to create special test samples, test them, and then dispose of them. So, destructive testing is often used in the design phase of new materials or products for quality control and during failure analysis. It provides quantitative material properties. Quantitative means to data or results that can be measured in numbers and measurements that define the material's characteristics. So, this is the destructive testing advantages and disadvantages. Next, we are discussing about non destructive testing. So, non destructive testing allows us to inspect materials without causing damage. This is the fundamental difference from destructive testing. Destructive testing means damage or destroying the material, but here without causing any damage we inspect the material. The main purpose of NDT is to detect flaws or defects without altering the part. This is the main purpose. We want to find problems like cracks, voids, or inconsistencies without breaking the item. Imagine you have bought a brand new expensive bicycle frame. You want to be sure there are no hidden cracks inside the tube from manufacturing. You can't smash it with a hammer to check, right? NDT methods allows us to see inside or find the tiny surface flaws without damaging the frame, so you can still ride it safely. NDT is widely used in maintenance and safety inspections because the component remains intact. Same non-destructive testing also have many methods. Here I mentioned conventional methods for sample: ultrasonic testing, radiographic testing, magnetic particle testing, and dye penetrate testing. These are the conventional methods of NDT. These visual inspection testing and electromagnetic testing, these are the eddy current testing, these are the advanced techniques. Same here also, these methods having separate insights. For example, ultrasonic testing. This methods uses sound waves to detect internal flaws. We send a high frequency sound waves into the material. Now we used a probe. Here ultrasonic testing, we using a probe. This probe contact with the material, directly contact to the material, and it gives a signal to the signal or sound waves will bounce back differently. If there is any flaws, the sound waves will bounce back differently. So it reveals the defect. It's similar to how bats use sonar to navigate. So, like radiographic testing uses X-rays or gamma rays to inside the material. Just like how doctors use X-rays to see your bones. If a X-ray means here our bones visible to the bright, or if we use them to see internal cracks, voids, or inclusions in metal parts. Next, we discuss about the advantages and disadvantages of the non-destructive testing. First, we discuss about advantages. The main advantage is that the part can be reused, the part for continued use, because it can't damage. Without causing any damage, we will inspect the material. So here the part or material can be reused, and it detects both surface and subsurface flaws. NDT helps us to check parts in service or during manufacturing without harming them. The actual component can be used again after testing. No material is wasted. This is the main. Generally less costly and faster. especially for in-service inspection compared to replacing parts. Disadvantages is that it requires trained personnel to interpret results and to accurately understand and evaluate them. So require the skilled interpretations, and some equipments can be expensive to set for advanced methods. So this slide shows difference between destructive and non-destructive testing in action. Here ultrasonic testing inspection, he is doing ultrasonic testing, and here the material is damaging. So this is a destructive testing, damaging and destroying the material. Here without any damage we inspect the material. So this is the basic difference for the destructive testing and non-destructive testing. This picture will help us to understand how these methods are applied in real world industrial scenarios. Next, a quick comparison of destructive testing and non-destructive testing. First, the destructive testing that damage or destroy the specimen. Non-destructive does not any damage the test specimen. For the purpose means to determine the mechanical properties of the material, here we inspect so to detect flaws or defects without damaging the part. So it defines the strength limits of material in destructive type. NDT ensures long-term safety and reliability in the material. Test specimens are usually scrapped after testing. Here we can reuse the component. After testing we can reuse the test specimen. Here the common methods are tensile testing, impact testing, bend testing, hardness testing, and fracture toughness testing. Here ultrasonic testing, radiographic, magnetic particle testing, dye penetrate testing, visual testing, acoustic emission testing. So many methods are in NDT. Cost and timing often more costly and time consuming, but non-destructive testing is less costly and faster, especially for in-service inspection. Some of the advanced techniques, they machineries are some costly. Some machineries are costly in the advanced technique. So applications often used in design, quality control and failure analysis. Here we using manufacturing, maintenance and in-service inspection. Result type means quantitative material properties. It provides quantitative means accurate performance data. Here qualitative and semi-quantitative flaw detection. Example, presence of crack. So where it presents and location, it will be shown in the qualitative and semi-quantitative flaw detection. I hope this detailed slide by slide explanation with simple examples has helped you to understand these concepts better. We will see the next video. Thank you.